Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
For today's lesson, we are going to learn about integration by parts. Have a look at the formula here. This formula is actually provided in the formula list. In case if you can't remember it, you can just refer to the formula when you are solving the question. So have a look at the formula. When you integrate something in this form, which is in the form of u times the dv dx, is actually equals to uv minus integration of v du dx. Have a look at this question. Solve the integration of 2x times e power 3x. You have to recognize these as a product of algebra and exponential function. When it's a product, in differentiation chapter, we need to differentiate it by using product rule. So same for the integration chapter. We have to integrate by using integration by parts. But before we can start to integrate it, actually, we need to rearrange the functions by using isolate. So what is isolate? I represents the inverse tangent. L represents the ln. The A represents algebra. T represents trigo. As for the E, it represents exponential function. So we have to arrange our product according to this sequence. The I comes first, then ln, then algebra, then trigo, then exponential comes last. How to make use of this isolate? Let's have a look at the question here. The 2x belongs to algebra and the e power 3x belongs to exponential function. So according to isolate, the algebra comes before the exponential, and therefore the one that appears first according to the formula will be our u. The one that appears later will be the dv dx. Okay, have a look at the question here. The 2x will be our u and the e power 3x will be the dv dx. And according to the formula, it should be equals to uv. So we just copy the u, which is 2x. And how to get the v when you are given dv dx? We will just need to integrate the dv dx to get the v. Same for this case here. We need to integrate the e power 3x. Then we will get e power 3x over 3 minus integrate v again. So it's the same as this v, and therefore now I'll just copy the e power 3x over 3, and the next one will be du dx, which means we just need to differentiate the u here to get du dx. And according to our question, our u is 2x, and therefore differentiate 2x, you should get a 2. That's how we make use of the integration by parts formula. So for now, have a look at the first part here. There's no more integration sign, which means for this part is already done. So I'll just copy it here, 2x e power 3x over 3. As for the second part here, there's still an integration sign. which means we still need to integrate this part. So before I integrate it, I'll just take out the constant, which is 2 over 3, and hence you just need to integrate the e power 3x. And therefore, integrate e power 3x, you should have e power 3x over 3. That's how we make use of the integration by parts formula. And since this question has no limit given, and we will just need to add in the plus c, the constant at the back. Let's have a look at another example. For this question, you are asked to solve the integration of 3x times ln x. You should recognize this as a product, and hence you need to use the integration by parts formula. So before we can start using the formula, we got to check the sequence of the product by using the word ILATE. So according to ILATE, for this product, this is algebra and this is ln, and therefore according to the ILATE, ln should come first before the algebra, and therefore the one that appears first should be our u. The one that appears later is the dv/dx. So now we can start to make use of the integrations formula. According to the formula, it's u and v. So first we copy the u, which is the ln x, and to get the v from the dv/dx here means we need to integrate the 3x, and hence we should have 3x squared over 2 minus integrate, according to the formula, is v du dx. So the v is the same as this v, which means we just need to copy 3x squared over 2. And du dx is by differentiating the ln. Differentiate ln is 1 over x. And hence, the first part is done. So I just copy the 3x squared ln x over 2. And please take note that this x squared shouldn't be multiplied into this x. They are two different terms. And for the next part, you have to simplify it first before you can further integrate it. So for this part, what we need to do is this x squared and the x can be cancelled off, and therefore we just need to integrate 3x over 2. For the first part is already done, so we just need to copy. As for the second part, integrate 3x over 2, we will get 3x squared over 4 and plus the c there. This is how we solve for this question. If you try to interchange the position of ln x and 3x and make the 3x as the u, ln x as the dv/dx, you notice that this integration by parts cannot be performed because the ln x is dv/dx. In order to get the v, you will need to integrate ln. But we can't just integrate ln in just one step. You need a few steps to integrate the ln. And therefore, you need to arrange it according to ILATE so that you can perform the integration by parts. Let's continue with another example. You are asked to solve for the integration of x and inverse tangent x. So for this question, it involves inverse tangent x, which is new in the syllabus. So please take note here. Before we can do the integration by parts, we have to arrange according to ILATE. So according to the formula, inverse tangent comes first before the algebra x in this case, and therefore we will make the inverse tangent x as the u, and the x here is the dv/dx. just copy the question here. And let's start using the formula. According to the formula, it's u and v. So we'll just copy the u, which is inverse tangent x. And v means we need to integrate the x here, which is x squared over 2. Minus integrate. And according to this formula is v again. So we just need to copy this, x squared over 2. And then du dx means you will need to differentiate the inverse tangent x. So this is provided in the formula list under the differentiation part, which is 1 over 1 plus x squared. Alright, so for the first part is done. So I just copy the x squared inverse tangent x over 2. Please remember, do not multiply this x squared into this x, as there are two different terms. And for the second part, I'll just take out the constant 1 over 2 and combine all the algebras as a single fraction, which is x squared over 1 plus x squared. Alright, let me copy the first part. And what to do for the second part? For the second part here, this fraction is an improper fraction. So before we can integrate this fraction, we need to make it a proper fraction. So how to make this into a proper fraction? We need to do the long division. So I'll do it at the side here, x squared over 1 plus x squared. So I make a 1 here, x squared plus 1 over negative 1. And therefore, for this part, I'll simplify this improper fraction into 1 minus 1 over 1 plus x squared. We'll need to make it into a proper fraction first before we can further integrate it. For the next step, as usual, you just need to copy the first part, x squared inverse tangent x over 2. As for the second part here, the half, you just need to copy and integrate the 1 minus 1 over x squared. So integrate 1, you get an x, and integrate 1 over 1 plus x squared. This is something new in the syllabus, which is inverse tangent x. And since there's no limits given, so you just need to plus a c here. That's how we integrate this, the one that is new in the syllabus. Now let's see how we can apply the integration by parts knowledge that we have learned earlier into this past year question. So have a look at this May-June 2018 paper, variance 32. Have a look at the diagram here. The curve equation is given, and it's mentioned that the M is the maximum point. So for part 1, you are asked to find the x coordinate of the M, which is the maximum point. This is about the differentiation chapter. So for now, we'll just focus on the second part. You are asked to find the area of the shaded region enclosed by the curve and the axis, giving your answer in the term of the E, which means you are asked to find the area of this shaded region. So before we can find out this shaded region, we need to know what's the limit here. So to find out this limit, you just need to let y equals to 0 to get the x-intercept, which means 1 plus x times e power negative 1 over 3x equals to 0. So it's either 1 plus x equals to 0 or e power 1 over 3x equals to 0. But for this exponential function, it's impossible to be equals to 0, and hence we reject this answer. And therefore, the x should be equals to negative 1. So this limit here is a negative 1. So for part 2, to find the area of the shaded region, it should be integrate from -1 to 0 for the curve, and the equation is given. So for this function, it's a product, and hence we need to use integration by parts. And first, we have to arrange according to isolate. So this is algebra, this is exponential function. So algebra first, then only exponential function. So it's already in the correct order, and hence this is the u and this is the dv dx. So according to the formula, you will need to have u and v. So first you got to copy the u, and the next step is to integrate the dv dx, which is the e power -1/3x. You will get e power -1/3x over -1/3 minus integrate v and du dx. So the v is the same here. Du dx means you have to differentiate the u, and it's a 1 here. As for the limits, you can just put a big bracket here from -1 to 0. We only substitute the limit into it after we finish all the integration. So for this part, first part you can actually simplify it and make it into -3 x plus 1 e power -1/3x. As for the second part, we will need to simplify it before we can integrate it. So I'll make it into plus 3. I'll take out the constant 3 and integrate e power -1/3x. So as usual, the first part I'll just copy it. For the second part, we just need to integrate the exponential function, and hence we will get this. And the limit is from -1 to 0. Alright, for now we can start to sub in the limits. So first we sub in the 0, we should get a -3 minus 9. And when we sub in -1, we will get a 0 minus 9 e power 1/3. And hence the final answer should be equals to 9 e power 1/3 minus 12. That's how we make use of the integration by parts formula in this question. That's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.